Welcome. In this video, we'll walk through solving an equation that combines several key function concepts. By the end of this session, you will be able to solve an equation that involves inverse functions and composite functions. This means you'll be able to find the value of x that makes both sides of the equation equal. Let's look at the problem we're going to solve. We are given two functions, f and g. The function f of x is defined as 3x plus 2. The function g of x is defined as 4x minus 12. The equation we need to solve is f inverse of x equals g of f of x. We can see this involves finding an inverse function and a composite function. Let's start with the left side of the equation, the inverse function f inverse of x. To find the inverse of f of x equals 3x plus 2, we follow a standard procedure. First, we write the function as y equals 3x plus 2. The whole idea of an inverse function is to swap the roles of x and y. So that's our next step. We swap x and y to get x equals 3 plus 2. Now we need to solve this new equation for y. This will give us the expression for the inverse function. We start by subtracting 2 from both sides, giving us x minus 2 equals 3. Then we divide both sides by 3, which gives us y equals the quantity x minus 2 divided by 3. This expression for y is our inverse function. So, we've successfully found the inverse. Therefore, the inverse function f inverse of x is equal to x minus 2 over 3. Now let's turn our attention to the right side of the equation, the composite function. The notation g of f of x means we take the entire function f of x and substitute it into the function g of x. It's like plugging one function into another. Let's start with our outer function, g of x. The function g of x is 4x minus 12. For the composition g of f of x, every x in the expression for g of x gets replaced by f of x. It's a direct substitution. We are finding g of the quantity 3x plus 2. So, g of f of x is equal to 4 times the quantity 3x plus 2, and then minus 12. Notice that 3x plus 2 from fx has replaced the x in 4x minus 12. Now we need to simplify this expression. We'll use the distributive property. Distributing the 4, we get 4 times 3x, which is 12x, plus 4 times 2, which is 8. So we have 12x plus 8 minus 12. Combining the constant terms, 8 minus 12 is 4. This gives us our simplified composite function. G of f of x equals 12x minus 4. So we've now found and simplified both sides of our original equation. We've done the hardest part. Now we just need to solve the final equation. Let's put the pieces together. We have the left side, f inverse of x, and the right side, g of f of x. The left side is the quantity x minus 2 divided by 3, and the right side is 12x minus 4. We set these two expressions equal to each other. This is now a linear equation. Let's solve for x. A good first step is to eliminate the fraction. To get rid of the denominator 3, we can multiply both sides of the equation by 3. On the left, the 3's cancel, leaving x minus 2. On the right, we must distribute the 3, giving 36x minus 12. Great! Now the equation is much simpler. We want to gather all the x terms on one side and the constant terms on the other. Let's move all x terms to the right side and constant terms to the left. Subtracting x from both sides gives 2 equals 35x minus 12. Adding 12 to both sides gives 10 equals 35. Finally, we divide both sides by 35 to isolate x. This gives x equals 10 divided by 35. We can simplify this fraction by dividing both the numerator and denominator by 5. The final answer is x equals 2/7. So the value of x that satisfies the equation is 2/7. This is our solution. To be completely sure of our answer, we can quickly verify it. It's a great habit to get into. We'll substitute x equals 2 to 7 back into our original equation and check if both sides are equal. Let's start with the left side, that's f inverse of 2. Plugging into our expression for f inverse, we get 2/7 minus 2, all divided by 3. 2/7 minus 2 is 12/7. Dividing by 3 gives 4/7. So the left side is negative 4/7. Now let's check the right side, g of f of 2/7. Plugging into our simplified expression for g of f of x, we get 12 times 2/7 minus 4. This simplifies to 24/7 minus 28/7, which equals 4/7. So the right side is also negative 4/7. Since the left side equals the right side, our solution x equals 2 to 7 is correct. Let's quickly recap what we did. We started with a complex equation. First, we found the inverse of the function f. Then we found the composite function g of f of x. We set the two results equal to each other and solved the resulting linear equation. Finally, we verified our answer by substituting it back into the original equation. You are now able to solve equations involving both inverse and composite functions. Great work!